I'm going to take a quick run through a linear function and its inverse and how we can kind of visualize that on a graph. This is a method that I'll use for all different kinds of functions later on in the course. This linear function is f of x equals 4x minus 8. To find its inverse, set it equal to y. Swapped x and y, we should be kind of swapping inputs and outputs with the inverse function, and solving for y. I get it to, I could have x plus 8 all over 4, or 1/4 x plus 2 in y equals mx plus b form. One big thing you'll notice is that the inverse function has sort of the same steps but done in an opposite order and in an opposite direction. So like I said, this could be written as x plus 8 all over 4. And if you look at the order of things happening to x, it's being increased by 8, then divided by 4. So if you reverse those steps, the last step, division by 4, is going to become the first step here, multiplication by 4. And the next to last step, the plus 8, is actually a minus 8. And you can look at that either direction. These two functions should sort of undo one another. We think of the inverse as the undo function. Now looking at that in a graphical sense, I cannot go into Desmos and type f superscript -1 because it's going to think of that as a -1 power. It's a really big flaw in the notation among others. Now what I do is I always just do f of x and g of x for the function and its inverse. I've typed those in. We can see the two lines. Red is the original function, blue is the inverse. They cross where the x and y are the same. It's kind of looks like just a fraction there. And otherwise we see that these are kind of a reflection across the line y equals x. So I'll add that in. I like to make that one a dashed black line like this. And so that looks good. It looks like x and y is being reflected. We can investigate further. Go to f of x and click the click the edit list button, convert to table, and take a look at those points. We've got really nice, neat points from -2 to 2 there. It's kind of a lot. I'm going to just remove this last one just to reduce that list down a little bit. We don't need quite as many points. So I've got 4 points there. You can see them on the red line there. Just do a little adjustment and zoom out. The last one is the point where they cross. Now that's 2.667. It's actually 2 2/3. If I look at 2 2/3 just off to the side here, that's 2 times 3 is 6 plus 2. That's going to be 8/3. So this is the point when x and y is the same. It may not happen on every graph, but it does happen on this graph. So I'll go and put that point in there as well. That was 8/3, 8 divided by 3, same x and y. Now let's check those same points with the g of x, or the inverse function. Now I can't use the same x's because remember we're flipping x and y. So the output becomes the input. Let's put those in our x column, -12, -8, -4, 0. The first ones are just 4 apart. And then the last one's that 8/3 where they meet. So now the outputs were my original inputs. Those two tables are perfect reflections of one another, flipping the inputs and outputs, and you see that kind of magical relationship going on right there, diagonally across that y equals x line. Okay, the last thing I like to do is to plug the composition, plug the inverse into the function. So this is the composition of the function and its inverse, and that will replace that y equals x line, because when I plug the function into the inverse or vice versa, it cancels out. For example, here's the inverse plugged into the function. Function is 4x minus 8. So you can look at it that way. The inverse function is 1/4 x plus 2. You could also look at it this way. So you'll see these kind of halfway points for the notation. Either one works. You should get there. Basically 1/4 x plus 2 gets embedded in for the x. So we got a couple different halfway point or intermediate points, different ways to look at that, to piece it out and get to that answer there. Now if we distribute that through, 1/4 times 4 is just x plus 8 minus 8 equals x. So we end up with f of f negative 1x, so function inverse composed into the function equals x. That basically means the undo function's working. All the adjustments of the function are being undone by the inverse.